After you've created a Pchart, you might be interested in comparing the phases for statistical differences. The Pchart is based on the binomial distribution, so one way to do this is to compare the rate of success from one phase to another and testing for differences using the binomial distribution. SSDforR, this can be accomplished fairly easily in two different steps. I assume that you've already created the Pchart. If not, go and take a look at the video on creating a Pchart. We also assume that you have R 3.0 and Visual Studio installed. If not, go back and take a look at our instructional videos on installing R and RStudio. If you have R 3.0 installed, be sure that you have the patch version installed. There are some minor incompatibilities with SSDforR and the official release of R 3.0. If you need to install the patch version, just go back and look at those videos on installing R on our website, SSDanalysis.com. You could also follow us on Twitter, SSDforR, and you can find us on Facebook searching SSDforR. Okay, so the first thing we need to do then is load the package, which brings me to another assumption that you've already installed the SSDforR package. If you haven't installed it, go back and take a look at Getting Started video on the the SSD Analysis website. Okay, I'm going to click on Packages and I'm going to check this box here. Excuse me. Next to SSDforR, and that will load the package. If you wanted to, you could also in the console type require and between parentheses SSDforR. Be mindful of the case, do it exactly as I have it here and hit enter, and that's another way to install the package. Okay, the next step, if you haven't downloaded the Pchart data from our website, you need to do so for this example. So I'm going to click on my browser, Safari, and I'm going to bring up the website www.ssdanalysis.com, and I'm going to scroll down and I'm going to go to the Pchart example, and that's what the data looks like if you just click on it. But if you want it to download it, you need to right click it, and I'm using a Mac, so it's asking if I want to save the link file as, which I do. That's what I want to select, and the title is pchart.save, and I'm going to save it to my desktop. I want to click on save. Now it queries me if I want to append text to the end of it or don't append it. Click on don't append. If you're using a PC-based machine, you won't get that message. Just a message something like save target file as, and just save the file on your desktop. Okay. Once you have that downloaded, you can and you have the package loaded, the next step is to open the dataset. So I'm going to type in the command get CSV, and I'm going to go to the desktop and going to search for my Pchart data set. There it is. And now I'm going to attach it. Just follow those instructions, and between parentheses I'm going to type SSD, and anytime you open a file, it is placed into a vector called SSD, so that's what you'll be attaching. Now click on or type list names and open and close parentheses. That will give us a alphabetical listing of the variables in the data set. If you wanted to obtain a listing as it appears in the file itself, in the order in the file itself, then names in between parentheses SSD will accomplish that. So we have three variables: truancy, wtruancy, and ptruancy. Truancy is the behavior variable that is measuring the target behavior truancy. 1 means that they've attended, and 0 means they were truant. And wtruancy is the week of truancy, which you used in the previous video, which defines what sample the observation belongs to, and which is in weeks, week 1 through 15. And then we have ptruancy, which is the phase, A or B, so that an observation could either be in the baseline or in the intervention. This is a simple A-B design. So now if we wanted to compare these two phases in terms of success, we can use the binomial test. So let's click on the hyperlink to SSDforR, which will bring up the help files, and the function is called AB binomial. So let's click on that, and you could see what the usage is. So we need, there's the function itself, phase x, which would be the phase variable, which would be ptruancy. V1 refers to the letters assigned to the phases you want to compare. So A would be V1, and which is the baseline, because we're comparing baseline to the intervention, which would be, and V2 would be B. And then the success rates for each. We don't have the success rates directly, however, you can easily obtain them by simply using the R tables command. If you type table and open parentheses and then the target variable truancy, comma, ptruancy, it will give us a contingency table. And so we're interested in the number of ones. That means how often they attended. And so in the baseline, which is A, they attended 9 times and 60 times in the intervention. So the success rate then for A would be 9, and the success rate for B would be 60. So now we have all the information we need. So let's do the command then. AB binomial, and we're going to put in our phase variable, which is P truancy, and between quotation marks A, and between quotation marks B, and then our success rates, which are 9, 9, comma, 60. Notice that each one of the arguments are followed or separated by a comma. So we have P truancy, comma, and then a, comma, and so forth. Alright, now we're ready to run it. Hit enter, and we get our results. So you could see that there were 77 trials or observations during the intervention, and the p-values in scientific notation, given that it's a -16, we know that it's a fairly small significance value. But if you wanted to remove the scientific notation, you could type SN, open, close, parentheses, copy the notation by highlighting it and pressing Command C on a Mac or Control C on a PC, and just copy it here by pressing Control V on a PC or Command V on a Mac, and hit enter, and you can see it's a very low significance value. But there's some more interesting data here. Here we have the alternative hypotheses. True probability of success is not equal to 0.321, which is the success rate in the baseline. So 32%, 32.14% of the values in the baseline were successful, as compared to 77.9% in the intervention. So there's a fairly large increase from baseline to intervention. Okay, that concludes the video.